Welcome back to week 3 of Cube for All. Today is an exciting topic, and it's something that is closest to my heart, like app modernization and where do we start and where do we stop. Do you know that 74% of the app modernization projects fail? And one of the most common reasons for these projects failure are the complexity of the project of complexity of the modernization, and also the rigid architectures, right? So modernization is more or less like, peeling an onion. Like, you don't know where to start and where it ends. And when it comes to rigid architectures, it is also about how the applications are architected and how the DevOps strategy is being laid out, right? So today I'm going to share a very formulated, or rather a template by which you can take your apps and then modernize your applications, right? So it's going to be a step by step process. Before we start doing that, I want to give a quick recap of what we covered last week, and then I'll be walking you through the process of preparing your applications, and then containerizing and deploying your applications, right? And finally, as a bonus point, I'll also show you how to generate the Helm charts automatically. So last week we had Gayatri presenting the steps to install gopaddle lite, which is basically preparing your environment for modernization. Gopaddle lite is a community edition from gopaddle team, and it's a lifetime free edition which you can install on your microKDS environment, and it can be on your laptops, in your cloud environments, or even in your on-premise environment. It's a single node environment. And here are the steps where in just two commands, you will be able to bring up your lite environment. So today's, the process will be covered using this lite edition. However, I'll be sharing the strategies on how to prepare your applications, and that is totally independent of gopaddle lite. So here are the four different steps in which you can start preparing your applications. While your lite environment gives you the DevOps platform or your automation, but apps are yours, so you have to do some prep work before you start modernizing it. So the first step here is to build your applications, to just deploy, build and containerize your application in your development environments, right? So it's building in your development environment. So we have some quick start wizards as well that to guide you through this prep work. So we have a quick start wizard, which I'll show you in a moment. And we also have a command line utility, which you can download, and you can start onboarding your applications or containerizing your applications for your local development environments. Then you can optimize this and build your applications using multi-stage builds. So there is a very small set of steps that you can follow, which will automatically enable your apps with multi-stage builds. Then you can add portability to your app. So here you can introduce config maps. So there are a few options through which you can do this. I'll show you one of the options as a demo. And then you can add specific network policies, access controls, and things like that. All right. So let's go through the first step. Before that, so this is the overall support matrix. So in case you want to know what types of applications can be containerized, with the gopaddle, you have these different options through which you can containerize and deploy. You can use the basic platform and use the gopaddle user interface directly. So we have a wizard-based approach of onboarding the apps, and we have a command line utility called GPCTL, which will help you to discover and deploy your applications. And we also have a quick start wizard, which is a part of the user interface. So we have three different ways in which you can modernize. However, the types of applications that we support through these tools or the platform are long running services, right? So it has to be a service, and it cannot be a terminal based service. We don't have a support for terminal based services. and it cannot be a library or a utility. If it is a long running process, then we support all types of Linux based workloads like Java, Node.js, GoLang, Python 2.3, and .NET Core, right? And that's supported across your gopaddle UI as well as through the command line utility. However, with the Quick Start Wizard, we still don't have support for .NET Core, and we have support for the other types of languages. The base OS from which you modernize, so since it's a user for, in case of user interface, since it's a browser based wizard, we support all types of Linux environments, whereas this command line utility and the quick start wizard require some support from your local environment like your desktops, and we only support Ubuntu 18.04. The applications can be onboarded from any of these source control repositories. It can be GitHub, GitLab, or Bitbucket in case of the UI. Whereas if you are using the command line utility or the quick start wizard, we have only support for GitHub based source control repositories, right? So with this preset, let's get started with the phase one, which is to building for your local environments or for your development environment. So this is the very basic step, right? So you must have this setup before we start optimizing and then adding more capabilities. So this is a template which you can follow, and you can start collecting information about your applications and your base platform. So when you suppose, let's take a Java based application, right? I'm going to show you a couple of examples there. So you know what is the base OS here. So we have, say, Ubuntu 18.04. So your applications are running on Ubuntu 18.04. And then you have OpenJDK 11, right? So you need these two in order. This is the basic setup that you need in order to run your application. Then you know how you're building your application. Say in our case, we need Maven, and if you're using Ant or Gradle or any other build tools, you know like what kind of SDKs and packages you need in order to build and to run your application. You need an optimal capacity. So in our case, let's take the highest capacity that you need. So suppose your build phase consumes more RAM, then you take the highest capacity. So in this case, say let's take 2 GB of RAM is what we need in order to build and run your application. And any type of environment variables that you need to expose, right? If it is a two-tier application, your Java application may in turn make calls to your databases. So you may need some connection strings, and you may want to keep those in the form of environment variables. Next is the user IDs. It's better to start with a non-root user. So when you are running in your laptop, so it usually, your user ID becomes the UID that you need in order to containerize and run your apps. So it's better to start with a non-root user right from day one, because you will unearth a lot of other challenges as you start introducing these security policies later in the cycle. So it's better to start identifying that. So if you are running as the UID 1,000, 10,000, 1,000, then like you have to introduce this from day one. Then you have these scripts. Right now this is very specific to your application, so you need to have 4 different scripts ready, right? So one is your build script, so it tells you how to build your application. You have your start script, which tells you how to run your application. And then you have a health check. If you have not introduced a health check API in your application, you can also, if it's a service, so you can also use the curl command to know whether your application is running on a specific port, right? And then you have the stop script, so which gracefully exits your application. So we just need these 4 different types of scripts ready. So once you have this, almost your 30 to 40% of your modernization work is ready, because like you can use the tools that I'm showing you to just get all these Docker files and Kubernetes YAML files automatically generated, right? So couple of things to remember. The first one is, you must, when you are starting your services, you must ensure that it is listening on an intended port. All right. Say for example, in case of Node.js, in some cases, like it's supposed to run and listen on port 3000, for instance. However, if there is another instance that is already running, which has taken up this 3000, then it may automatically bring up your service on 3001, right? However, when you are finally deploying to Kubernetes, you want your application to listen on 3000, right? So in that case, you must ensure that before you start using any of our tools, you must ensure that your service is listening on 3000 and not in 3001, right? So that is a critical step that you must ensure that it is listening on an intended port, or you can configure in your in your application scripts to make sure that it is always starting in a specific port. The next one you have to ensure is that your service is listening on 0000, where globally, any service can connect rather than connecting to the local host. This is required when you have to access your application outside through the browser, right? If it is just a process that is running inside your container, then it's perfectly fine. But if you want to access this outside, you must you must make sure your service is bound to this 00 IP, right? So just this step, and then your almost half your process is ready, right? So now what we have to do, so once you have these scripts ready, we will be using a quick start wizard. So last week we saw how to bring up the gopaddle lite environment. So you have it running in your local environment. So we have this option of a quick start wizard where we will set up the environments, because you need a Docker registry where you will build and run your application. You will have a source control repository from where you will clone the project, and you will also need the allocation policy. So based on the capacity, you're going to build and run your application in your local Kubernetes environment. So we are not going to set up a separate build environment. While that is still possible through a gopaddle, we are not going to do that. We are going to just keep this whole setup to the minimal, or rather a consolidated environment where the whole build and run will happen in your local cluster itself. Later on, you can go ahead and then add additional environments, like you can have GitHub Actions where you can build it separately also. That is like if you want to extend, that is still possible. But if you want to contain everything in a single environment, we are going to do that step now, right? And then we will Dockerize. So where the quick start wizard will in turn make use of our command line utility only, but it will discover the application, it will generate the Docker files, it will build, and it will push the images into your Docker registry. Once the Dockerization is complete, then we have the cubification process where we will generate the quick start wizard itself will generate all the YAML files, and it will deploy the application to Kubernetes. So this whole process is just one step, and it will be totally seamless during this process. So let me stop here, and I want Gayatri to share the screen where she is going to run you through the quick start wizard quickly. So this is the gopaddle UI, and we can open up the quick start wizard. So as soon as you start the quick start wizard, you will see a gopaddle API token. So this is automatically generated in your local lite environment. And in case of enterprise editions and other editions, we will have to generate this token separately from the profiles page. But for the lite edition, this is automatically generated. So you can just go with the default token for the time being. And once we have this, we need to choose the cluster. So in our case, this is going to be the local cluster itself. So this is your local microKDoS environment. So here your build and deployment will happen on this cluster itself. In enterprise editions, you will have an option to choose other clusters, but for lite, it is your local cluster itself. So the next step is to onboard your registry. So this again, we can use any pre-registered registries that are already available in your environment. Otherwise, we can register a fresh new environment. So here, all you have to do is to, if you have a Docker registry, you can go to the settings page, account settings, and then under security, you can create a new access token. Okay, and then this will auto generate a token. It will generate a token which you can copy and then add it to the you can add your username and the token, add a registry name, and then you have to keep the Docker hosted registry option enabled, right? So this is your Docker hub registration. Suppose if you have Docker, I mean a Harbor registry, which is self-hosted in your local environments. We support Harbor registries as well. In that case, you can create, if you go to our help documents, you'll find steps on how to create this access token. And then you can disable this Docker hosted registry option, and then you can register it. So you have steps how to do it in help.gopaddle.io on how to register a Harbor registry with the GoPaddle platform, right? So once you have the registry, so in our case, we are going to use a pre-registered registry. We have a GP demo, so we'll choose the registry here. And then we have to create an allocation policy. So as I suggested earlier, we have made a note of how much of capacity we need in order to build the maximum capacity either for run or for build. So I'll show you the steps on how to separate this out later in the multi-stage builds. But for the time being, we are going to use a single allocation policy. So this tells you how much of capacity we need in order to build and run, right? So we will choose an existing allocation policy in our case, which is, yeah, so here you can see this has 800 millicore and 2500 millicore of CPU requests and limits and 1 to 2 GB of RAM. So this is going to be consumed in your clusters. So if you remember, we have actually allocated extra capacity when we provisioned the VMs in the last week, because we need additional capacity for building and running your applications. So we have 2 GB of capacity in this environment. So we have set it to maximum 2 GB for this particular application. Yeah. So here is where you register your source control repositories, and if it is, you can choose either to either it can be a public repository or it can be a private repository. So here we can just give the GitHub token and then register. So we only support GitHub token-based authentication with the Lite edition, but you have support for single sign-on and more sophisticated options in the enterprise edition. But here we will just go with the token based authentication. So if you go to your GitHub account, under settings, you can choose the developer settings, the last option there, and you can create a new personal access token. So you can generate a new token, and then you have to just enable your repo access to it. So you have to just enable repo access, give it a name, and then this will generate a new authentication token, which you can just copy paste into your yeah. Yeah, you can just copy paste this into your quick start wizard, and this should register your private registry. We already have registered this account, so we can just choose one of the existing source code accounts, right? Now there is an option of choosing your public repos. If in case you're not using the private ones, you can also use your public source control accounts. The only difference is that you will not have a continuous integration automatically enabled for this. because we will not be able to add any webhooks or anything to this particular repository. So you can probably fork your fork the code. If it is a public repository, you can fork it to your local environment, to your local GitHub repo, and then give a private access to it, right? So yeah, so for now we are going to use the private source control account. And then here you can give the repository URL, right? I'm going to choose one of the, so we have support for specific versions of, the project types here, like Node.js, Java, Python, GoLang, and we don't have support for .NET Core. This is still an upcoming version release. So .NET Core is listed here, but we still don't have support for it, right? So we have Node.js. You can choose, in our case, we'll choose Java, and this will automatically choose a base image, right? You can go override this. However, it has to be a open JDK version, right? As I mentioned in the support matrix earlier, it's not limited to OpenJDK. You can have other types of platforms as well, other versions of Java versions as well. But through Quick Start Wizard, this is what is supported. You can refer to that support matrix, and then you can take a look at other options later, right? So we are going to provide the project URL, and you can also enable build on commit and vulnerability scans. So what happens when you enable build on commit? So this option is not available for a public repo, but since it's a private repo, you see this build on commit option. So this will automatically trigger the continuous integration, right? So if any code change happens in your project, it will automatically build and then push your Docker images to container registry that you just now onboarded. And vulnerability scan will automatically check for vulnerabilities, and you will be able to see all those reports in your build reports. You can choose the repository, and then here is where you will add environment variables. So if you click on add, you will see options to add the key and the value pairs. Gayatri, can you click on add? Yeah. So you can give a name, a variable name and a value, and then you can add. So suppose if you have a database connection string, you can add all those information here. It is useful to add such information in envs, because when you want to have different databases for your development stage in production, you can expose different environment variables. I'll be showing those options later, but you can expose those envs in this. So in this case, this demo application is a single tier application, so we don't have any such requirements. So we are going to move on. Yeah, here is where you will key in all your scripts, right? Whatever scripts you had created for building, starting, checking for health, and stopping your application. So the quick start wizard gives you a pre-built template of how to build, how to run. You can go modify this, right? This is though it does some sort of multi-stage build, you still have to enable a few things later. So for now, we are going to build for development environments, so this should be fine. We can just move on, right? So this will you can download the scripts. This will download a tar file in your local environment, and you can extract it from here. So once you extract, you go to the scripts folder, and then just copy paste your current folder from here. So what we are going to do is to run this onboarding process from your local environment. So you need to have Docker enabled, Docker process daemon running in your local desktop, right? So we'll just key in this extracted scripts folder, copy this complete Dockerization command, and this is going to generate all the Docker files and the YAML files for you. So it's one command which gives you all the the DevOps setup, your Docker registries, your source control repositories, everything tied together. Build it, push the images, and then create the Docker files, and then it's going to deploy to your local Kubernetes environment. It's just one step process. Once you have that template ready, it's just one step process for you. Yeah. So what is happening here is that it is cloning your project in your, so this is going to bring up one quick start Docker image in your local environment. And within that quick start image, it is actually cloning your project It is discovering your application. Say in this case, it's a demo Hello World Spring Boot application. It has discovered a few environment, like it's a Java application, and it is discovering all the environment variables that are available to you, right? All of this is automatically discovered, and then it's still running the discovery process. So this is going to take a couple of minutes. So I'm going to pause here, and then I'm going to show you a similar application, and then we will talk about a few strategies to follow. Right. So let me share my screen, and then I will show you a different application of similar nature. We will go back to that demo application in a while. So one thing to keep in mind, which I actually missed to mention, when you are preparing these scripts, the best practice is to take one of those base images which I described earlier, which is for Node.js. It is Node version, specific version, or in this case, it's OpenJDK 11. So we have some default base images that are supported in the Quick Start wizard. So when you are preparing these steps, you can actually do a Docker pull of that particular base image, and within that base image you can start preparing all of this. So that will kind of avoid all the unnecessary hiccups that you may face later on, because for sure that your build and your run is going to happen within that base image. So you can just pull that base image. Within that you can start preparing this scripts, all these scripts and these templates, and then during the quick start wizard you can choose the same base image for your build and deploy. Okay, so we will come back to this. I will show you how the whole quick start runs and what it does. So next step is to enable the multi-stage build. So this is so we saw how the Dockerization works. Now we will have to split this into two different steps, right? So you need to have a separate set of base images for build process, and a separate set of base image for your running process, right? So you need to start segregating your the packages and the SDKs that you need for different stages. So for example, for building phase, you need Maven, whereas in runtime, you don't need Maven, right? Now, similarly, you may need a higher capacity at the time of build, and you may have a lesser capacity at the time of run, because Maven build takes more memory, right? Similarly, for environment variables, you need a separate set of environment variables. In this case, it may connect to a different database. So you need to kind of segregate these, and then have a template like this, right? So you know what you need for a base image. The SDKs and packages will go inside your base images. That's more or less, these are static set of packages that you need, whereas your artifacts are going to be more repeatable. So you will start preparing a base image of your own, right? And then you will come back and then see how much of capacity you need for each of these different phases. From gopaddle, there is only one small thing that you have to do, which is to just set up your output directory at the time of build. Say in our example, in our Java example, like when you run your build script, it's going to create a jar file inside your target folder, right? So you don't have to copy the entire source code into your runtime environment. You just need to copy your jar file alone into your runtime environment. So let's take, for example, I have another Java application, a Spring Boot Pet Clinic application. So this is your gopaddle user interface. So from your containers page, you will be able to see all the containers that are getting onboarded. Looks like the quick start wizard that we are running has not created the container yet. We will be seeing that in a moment, right? So it is still in the process of creating all these resources. But once the quick start wizard is ready and your application is deployed, you will be able to see those resources here. So you can see it is just still waiting for, it's still getting onboarded. Okay. Now let's take this Pet Clinic application for a moment. Sorry. So this is the container where you have two tabs. One tab tells you all the properties that are related to Kubernetes, right? So you see all the the security aspects, network aspects, health checks, and all your routing, ingress rules, storage, configuration files, environment variables, and everything. So here you have a start script which tells you how to start your application. So this is a part of your Kubernetes related configuration. You have a build configuration which is specific to Docker related builds. So under this, you can actually go to, you can view these build configuration and you can see the build script here, right? So this tells you the build script that you have provided, right? In this case, we have a couple of steps to build your application. You can actually move all of this. So as I said, we have identified a few packages. In this case, I think the base image that we are using to build is Ubuntu. So we have all these, but you can build a specific base image. You can move all of this inside your base image itself as a build base image, right? And then you can just have a Maven clean install. So this is a different application. So here it is not optimal, but in our case, it is optimal through Quick Start Wizard. So let's just add an output directory for this. So when I build this, this is going to create all the jar files under the target folder. So all I have to do is to just give /target, and it is going to pick the artifact from this target folder and just build a Docker image by copying all the contents within that target folder. So when I actually do another build, this is going to build a separate image, right? With whatever changes I made. In the meantime, we also must go to the start script and then change the start script, because it's not going to pick from target. It is going to just run from the root folder itself. So only these two changes and your multi-stage build is done, right? So I will show you with respect to an application. So that whatever I showed you is just a template. Now, when you run this, you will get a running application, right? So when you run this, you have a running application and you have a service called Pet Clinic in this, and you have artifacts where you will maintain all these templates that I mentioned will be under the artifacts, and a running version of it will be under your replica. So you go to this replicas and you will see a container within that, and you can log into this container and then you will see what has happened. So it is currently, it is not running in multi-stage build. It has copied all the contents within your project root. So you will see even your source folder and the target folder and everything. All we need is just the target, right? So you will see there is a jar file that we just have to copy, right? So what I did earlier was to just change the template. Until you deploy it, you will not be able to see those changes. But I already have an application running using that template, so I can go and directly edit the application itself instead of relaunching it. So what I'm going to do now is to go and take this service and change the artifact. But before I do that, I need to just do two things. One, you need to see whether I can do a rolling update with the new build that I did, right? So I can actually go to, sorry about this, hold on. Okay, so I'm going to change this one. But before I do that, I have to do make sure that the update that I did, the new build is available. I'm going to do a rolling update with the build configuration changes I made, and then I'm going to just change the start script from here, right? So it's going to be just a small change that I have to do to a running application. So let's before I do that, let's take a look at where the build process is. So you can see all the the repeated or the release related artifacts under release planning. So you can go to the builds. You can see whether your new build is complete. So looks like this is already complete. So we will have to, yeah. So you see that the pet clinic application is ready. So build is ready. So we have to just go update the application with the new build image and change the start script. So you go to the revisions, and then you can update the Docker image from here. So right now I have version 4. I have to change it to version 5, and then give a commit description saying that multi-stage build. And I save this. So this will do a rolling update of the image. So the image will have only your artifact or your jar file. And once this is updated, we can just go change the start script here. And I'm going to just remove this target. So all I need to do is only this. So remove target folder. Right. So once you do this, your application is now enabled for multi-stage build, right? So we'll have to wait for these replicas. So it has automatically brought up a new replica. Okay, looks like the rolling update is still happening. So it's going to take some more time for us. Okay, Gayatri, so is it going on still? So would you be able to check this update? Is it happening still? Okay, we will come back to this. So let's take a look at the containerization, right? So it will, so this rolling update may take a while. So we'll come back to that. I'm going to share what is happening on the quick start wizard. Okay, so we saw like it has started with the discovery. So it has run a few discovery process. It has built the container profile, and then it has created a couple of resources in gopaddle, like the containers, the repositories, the distributions, whatever is required in order to generate the Docker file. It has built the new container. It has pushed the image to the registry, and it has created a few templates called the deployment template. I will show you that what is a template and how you can generate Helm files from that. And then it has deployed the application also. It has discovered one of the node ports that is available, and it has done a port mapping, and it has launched the application as well, right? So the whole process, it didn't even take 5 minutes for getting this application up and running. And you can see the access URL. Now, this is showing a private IP of your application. However, if you had set a static IP address, like how we discussed in the last session, right? If you had set a static IP address or a public IP address, you will be able to access the application using the public IP address. And you must open this port 31898. If at all you're running this up in your cloud environment, you have to just open up the firewall port, and you should be able to access the application up and running in your environment. So it hardly takes 5 minutes for you to get the whole application containerized. So here we are running this microcaters environment in an AWS setup. So we have to just copy the public IP address of that environment, and your application can be accessed using that. Yeah, this is a hello world application. So you can see your application can be accessed. The time it takes to build depends on the size of your application and the size of the allocation policy that you have set, and also based on the size of your microcaters environment. So if you have a larger system, I mean, it will take like 32 GB RAM is what we have in this environment, which is running both microcaders, gopaddle lite, as well as your application. So it has just taken 5 minutes for us. Let's go back and then see the update on the Spring Boot application that Pet Clinic application that we saw. Let's see if it has come up. And we can log into the terminal to see if that application has the multi-stage build enabled. Can we go back to the application and then show this Pet Clinic application? So it has restarted, it has brought up replicas a couple of times, restarted, and then by now we know we should have the container up and running with all the changes that we did. Okay, so still it's taking time, so we'll come back to this in a while. Okay, so as I mentioned, it's all we had to do is to just change the output directory, build it once, and then in your running application you can go and change your start script to directly point to the root folder, and you should have your multi-stage build enabled with that. So let's go back to the next step. Okay, so we have seen the multi-stage build. Now let's go back to how to enable portability, right? All right, so portability is when you have your configuration files and other envs segregated from your docker builds and your kubernetes deployments. So one such resource that is readily available to you in kubernetes which will enable portability is your config maps, right? So if you have configuration files on how you bring up your application. Say, for instance, if your application has to connect to a specific database, earlier I talked about envs. Env is one good option, right? So you can expose those connection strings in the form of envs, and your application can make use of those envs. Another is if you have more configuration that is very environment specific, you can put all those configs in the form of config files. In most of the scenarios I've seen, like the config files are in the same folder as your source directories, whereas you must keep all these configs as separate folders so then you can mount them inside your deployments, right? So this is very very important if you have to enable portability. So you have to keep those configs separately. Now, there are two options on how you can add this config files to your application. So option one is you can have multiple config files within a single folder. Say here, option one, I have one config folder with app.dev.config, another is app.prod.config, where I'll be using a .dev for development environment and .prod for production environment, right? So this is I can segregate those different configs as different config files, and then I will use environment variables to pick the corresponding config file at the time of deploying or running the application. So if the env is set to prod, then I can choose the or copy this prod config to my main file, or my application can make use of prod config, right? The option two is to have two separate folders itself, say config dev and config prod, or have a set of files segregated like that. And you can have multiple config files mounted based on your env. So I'm going to show the second option on how this can be done through gopaddle. The first one is very application specific. All you have to do is to expose an env and use it in your gopaddle, right? So I'll show you the second option where you can mount these different types of configs into your containers, right? So let's go back to the UI again. I'm going to show this with respect to the Pet Clinic application, which we have already onboarded. And we have segregated the config files separately, right? So I'll go to containers under Pet Clinic. So here I can onboard a new config. So here I can give a config file name. Say this is config, and I can choose a file type, and I can mount. So here I can choose a config path on where it has to be mounted within your application. So I can give the path, and then I can give the mode. So this is the permission that we need in order to mount. Okay. And then I can upload a new set of config files. So if I have the tar files, I can upload it from here, right from my local desktop. Say if I have a config file created already within the system, so all those are available under the template. So I can create a config map afresh from here, and already we have two config maps created, right? So this is just a template. It is not a running version. So you see dev pet clinic and prod pet clinic. So under each of these, you will have a certain set of files. You can visualize what is there within these files. So we can upload multiple files, add like we have 3 files here. We can also add more files, right? You can upload multiple files and then group them and keep them, right? So this is one set of config files that we have for your development environment. You can also create another set of config files, similar files for your production. So now you can, by default, you can use one of these, and at the time of launching your application you can choose which one you want to which config map you want to use. So let's, for example, here I'm going to add an existing config map. I'm going to set it to default to pet clinic, and this is the draft version, and you can give the path here, and then you can add it, right? You can add this configuration. Now this is added to your template. Now this is at the container level. Now you can create your discovery process would have created all these services as well. The service is nothing but multiple containers put together. These are long running processes. These are equivalent to the Kubernetes services. So you will see under pet clinic I have one container also added into this, which is your pet clinic. And you will have a similar service for MongoDB also. A deployment template is nothing but you put multiple services together, and then you have a template. So this also would have been created during the discovery process. You will see multiple services here, but the discovery we have only one process for our other sample application, right? So you have the pet clinic application, and this has one container pet clinic, right? You will be able to see the configurations that we had mounted earlier, right? This is how it gets created, and then you can set the network. Okay, so the configs are created. So when you take this and then you deploy, you will be able to choose what type of config maps you want to use at that point. Okay, so the next thing that we need to do is to set the network access. So the network access tells you what sort of inbound and outbound network ports that we need for specific applications. So we have 3 layers of network policies that can be set. You can say within, like if you have a larger application with multiple services running within that application, say in our sample pet clinic application, we have MongoDB and Java Spring Boot application running. So we have 2 services within that. So if we want to expose, you know, certain inbound, outbound rules, we can have a service specific rule saying, MongoDB have to be exposed only to pet clinic application. Or if we want to give access to all the other services within that, you can give a broader set of rules, or you can set it to a specific CIDR or an external IP, so that you can say, okay, this service can be accessed from any CIDR range, right? So this is a network access that you can enable from your service. So you can go to the services option, and then you can say the same pet clinic application. You have all your policies defined, and here you right now it is using the default, so you can select this and then choose a pet clinic. Not here, I'm sorry, you're setting the network policy for your MongoDB, say, because MongoDB we can expose it to a specific pet clinic service. So we can go to MongoDB. I'll show you how it is done in MongoDB. So, or rather MySQL, sorry. So here you can edit this policy, network policy, and you can set it to MySQL pet clinic. So this will tell you this particular port has to be exposed to this particular service called pet clinic. So only pet clinic can access this MongoDB, right? So how these are available? So you can go to the policies tab. Under policies, under service, you can select network, and you can add a new network policy, and then you can add the ingress and the egress rules. So under ingress, you can actually add saying, okay, whether you want at the CIDR level or a service level or at an application level, right? If you choose a CIDR, you have to give the port and the CIDR range. If it is your service, you can actually specify the port and the name of the service. In our case, it's pet clinic, right? If it is within the application, then you select the or outside or to a different application, right? So here again, two categories. You can give access within the same application, or you can give access to another application with different, totally a different deployment or different application, right? So in that case, you will give the name of the application, right? So this way you can actually give ingress or the egress rules, and you're all set, right? So the remaining, monitoring, logging, alerting is all inbuilt into the platform. This is the enablement that you have to do specific to your application to make this whole the modernization complete, right? So I hope this has given you a way in which you can dockerize, deploy, and you can add additional capabilities to make it more um, scalable in terms of your build and deployment process. And in the upcoming sessions, we will see how using this we can actually have the complete CI/CD enabled. We will, in the next session, we will see how to build a pipeline using this. Hope you enjoyed the session, and we look forward to yet another session in the coming week. Thank you.